So this is quadratic expressions and equations 2. For you to be able to follow this topic, you need to have covered quadratic expressions and equations 1. So if you have not, you need to go back and have a look at that in our lessons. This topic, we will cover the following. The first one is factorization of quadratic expressions. The second one is completing the square. Number 3, solution of quadratic equation by completing the square. Then we look at quadratic formula. We got to formation of quadratic equations. Then we have graphs of quadratic functions. From there we go to graphical solution of quadratic equations. And finally, we will look at graphical solution of simultaneous equation. So you are all welcome. By the end of this topic, we have covered all that, and you should be able to handle any question in the KCSE exam and any other exam you may be doing, which has this topic as one of its content. So you are all welcome. So in this lesson, we are going to learn how to factorize quadratic expressions. You already did this in quadratic expression and equations 1. So we just remind ourselves. Then from there, we will observe the type of quadratic expressions. So the first one, we will take x squared plus 2x plus 1. So for us to factorize this, we need two numbers such that when we add the two numbers, a plus b, this should give us 2. When we multiply the two numbers, a multiplied by b, it should give us 1. So this we can take 1 and 1. When you add 1 plus 1, you get 2. 1 times 1, you get 1. So we rewrite our quadratic expression like this: x squared plus x plus x plus 1. So we can now factorize our quadratic expression. So here we factor out x. We will be left with x here plus 1. Here we factorize 1, so you have plus 1 into bracket x plus 1. So this is common, so we factorize that, we get x plus 1 into bracket. Here we will be left with x plus 1, so we have x plus 1. You observe that this and this are the same, so we can actually write this as x plus 1 into bracket squared. So that is one of the quadratic expression. The other one, we will say it is x squared plus x minus 6. So here the coefficient of x is 1, so we get two numbers. A, when you add to b, should give you 1, and when you multiply these two numbers, you should get minus 6. So we will take 3 and minus 2. So we rewrite our expression. We have x squared plus 3x plus this is should be minus so we have now this should be minus 2x minus 6. We factor out what is common here. It is x, so we have x into bracket x plus 3. Here we factor out minus 2, so we have minus 2 into bracket x minus plus 3. So now x plus 3 and x plus 3 is common, we factor it out, plus 3. So here we are left with x minus 2. This we cannot combine because they are different. Here is plus 3 and here it is minus 1, unlike the first one. So that's how you factorize. So let's have a look at two more quadratic expressions. We have 9x squared plus 6x plus 1. So to factorize this, we need to multiply 9 multiplied by 1. We get it is equals to 9. We get two numbers such that when we multiply them, we get 9. When we add them, we get 6. This is 3 and 3. So we write our expression 9x squared plus 3x plus 3x plus 1. Here we factor out 3x, so we will get 3x into bracket. Here we have 3x plus 1, close the bracket. Here we factor out 1, so we have plus 1. We are left with 3x plus 1. Now 3x and 3x plus 1 is common, so we factor it out. We say 3x plus 1 will be left here with 3 and here with 1, so we will say it is 3x plus 1. These are repeated factors, so we can combine them and say this is the same as 3x plus 1 into bracket squared. So that is how you factorize such an expression. We take another one, 2x squared plus 2x minus 4. So multiply 2 by minus 4, you get minus 8. Get two numbers such that when you add them, you get 2. When you multiply them, you get 8. So this is 4 and minus, this will be 4 and minus 2. So we have 2x squared plus 4x minus 2x minus 4. So we factor out 2x here. We have 2x into bracket. Here we'll be left with x plus 2. Then here we factor out minus 2. We will be left with x plus 2. Now x plus 2 is common, so we factor it out. So we get x plus 2 is common. We are left with 2x and minus 2, so we have 2x minus 2. And we cannot go any further because we cannot combine this since they are different. Now that is how you factorize that and this. So note the difference, that these are repeated factors, these are not repeated. So far we have discussed 4 quadratic expression. So we factorized this quadratic expression, x squared plus 2x plus 1. We got x plus 1 into bracket squared. Then we factorized x squared plus x minus 6, and we got x plus 3 and x minus 2. The other one is 9x squared plus 6x plus 1, and we got 3x plus 1. In this lesson, we are going to cover square. Completing the square is a method whereby we make any quadratic expression a perfect square. In our previous lesson, we had learned the difference between perfect squares and non-perfect square. Perfect squares are those quadratic expressions whose factors are repeated, like x squared minus 6x plus 9 is equals to into bracket x minus 3 squared. This is also another quadratic expression which has perfect squares. X squared plus 12x plus 36 is equals to x plus 6 into bracket squared, and the same case applies to this one. The other set are non-perfect squares. You can see their factors are not repeated, so these are non-perfect squares. So completing the square will enable us to make each and every quadratic expression a perfect square. So let's see how we go about it. So completing the square is a way of making any quadratic expression a perfect square. Let's take an example. We have x squared plus 12x plus 36 is equals to x plus 6 into bracket square. So let's observe, for us to be able to complete a square, let's observe those expressions which are perfect square. We say that we are dealing with expressions whose coefficient of x squared is 1. So a is equals to 1. So b is equals to 12 and c is equals to 36. Then from there, we find that what is the relationship between A and C? We find that when you divide 12, you divide by 2 and you square, you get it is equals to 6 squared, which is the same as 36. So we can say where 36 is our constant, so we can relate this and say, then if you divide B divide by 2 and you square it, it should be able to give you C. That is the constant of the expression. And remember, this is when the coefficient of x squared is equals to 1. So let's see whether if we take another quadratic expression which is a perfect square, the same relationship works. So let's take another quadratic expression which is a perfect square. That is our x squared minus 6x plus 9. When you factor out this, you get in bracket x minus 3 into bracket squared. So note here that our a is equals to 1, our b is equals to minus 6, and our c is equals to 9, positive 9. From there, we observe that when you divide minus 6, you divide by 2, and you square, it is equals to minus 3 into bracket squared, which is equals to positive 9. When you square minus 3, you get positive 9, which is our C. So you find that we can write a relationship between B and C, and say our B divided by 2 into bracket squared will give you C. You can try with any other quadratic expression which is a perfect square, and you will be able to find that the relationship work. So we are going to use this relationship, that is our b divided by 2 into bracket squared gives you c. We are going to use this relationship to be able to make any quadratic expression a perfect square. So note that. So in our example 1, we are going to see how we can find out what should be added to x squared plus 8x to make it a perfect square. So we are going to use two methods to show that. So the first method, we are going to say, if we write, of course, our a, we can say it is equals to 1, which is there. So we can write our expression as x squared plus 8x, and we assume that what is to be added is our c. And we have found that if an expression is a perfect square, then there exists a relationship where we have b divided by 2, or this squared should give you c. So that now that we have b, then we simply say that 8 divided by 2 into bracket squared should be equals to, this is 4 squared, which is equals to 16, and this implies that our c is equals to 16, and therefore we can say 16 it must be added to make this expression a perfect square. So if it would be it is a perfect square, then it should be x squared plus 8x plus 16. That is what should be added to make it a perfect square. So the other way that we can call it method 2, to show or to find what is to be added to x squared plus 8x to make it a perfect square, then we can write our expression like this. We say x squared plus 8x plus c, where c is a constant. If it is a perfect square, then it should give us factors that would appear like this. So that is x plus k into bracket squared, where k is another constant. So k is another constant. So from there, we expand the right hand side. So we say our x squared plus 8x plus c. When you expand this, you get it is x squared plus 2kx plus k squared. So that is the expression that you get when you expand x plus k. So we now have our expression. So you find that these two expressions are the same, and therefore the coefficient of x on the left hand side is 8, and the coefficient of x on the right hand side is 2x. So if they are equal, since they are equated here, then 8 is the same as 2k. So we can divide both sides by 2. We divide by 2. 2 divided by 2 is 1, and 8 divided by 2 will give us 4. This implies that k is equals to 4. From there, we find that c is equals to, that is a constant. The constant on the other side is k squared. But we have already found that k is equals to 4. Therefore, c is equals to 4 squared, which gives you 16. So implying that 16 is to be added to make it a perfect square. So, and that is how you work out that. Now, in this example, we are required to find what is to be added, and the term that is missing is the middle one. So, to do that, we can write our expression as x squared plus, let's say our coefficient of x is b, so we have bx plus 25. So we know the relationship that exists is that b divided by 2 all over squared is equals to c. So we have our c is 25, and therefore we should be able to find b. So b divided by 2 into bracket squared is equals to 25. We get the square root for both sides, so we will find that b over 2, which is the square root of the left hand side, is equals to the square root of 25 is 5. So from there we can now get the value of b. So b is equals to 5 multiply both sides by 2, so you get b is equals to 10. So b is equals to 10. So 10 is to be added, or 10x is to be added to make this a perfect square. So it would look like this: x squared plus 10x plus 25 is a perfect square. The alternative method of finding what is to be added is by writing our expression x squared plus bx plus 25 is equals to x plus k into bracket square, where k is another constant. So when you expand this side, you get our x squared plus bx plus 25 is equals to, this will give you x squared plus 2kx plus k squared. Now, the left hand side is the same as the right hand side, and therefore we can equate our c, since the two expressions are the same. So k squared is equals to 20 So in this lesson, we are going to learn how to solve quadratic equation by completing the square method. So we already have learned how to complete a square, that is to make a quadratic expression, any quadratic expression, a perfect square. So we are saying that the factorization method is limited to solving certain quadratic equations. We use other methods to solve this equation that cannot be solved by factor method, and the other method is complete the square method. Complete the square method. So we have an example of an equation which we cannot use the factor method. That is, we have x squared plus 6x plus 3 is equals to 0. Remember, when you equate a quadratic expression to 0, it becomes a quadratic equation. So a quadratic expression is not equated to 0, but when you equate it to 0, it changes to a quadratic equation. So this is a quadratic equation. In factor method, we are looking for two numbers. Let's say a plus b should give us 6, and when you multiply a multiplied by b should give us the constant, which is 3. So there are no two numbers that exist that can satisfy this condition, so that we use the factor method. Therefore, the factor method cannot be used to solve this quadratic equation. So let's apply the complete the square method and solve this quadratic equation. So our example here, use complete the square method to solve x squared plus 6x plus 3. Like I have mentioned, we cannot use the factor method to solve this equation. So we use the complete method. To start with, we take 3 to the right hand side, so we have x squared plus 6x is equals to, when 3 crosses the equal sign, becomes minus 3. Now we complete the square for the left hand side, that is, we look for what is to be added to the left hand side. X squared plus 6x plus dash is equals to minus 3. So what is to be added here to make this a complete square? And we can see the coefficient of x squared is 1. So we said that when the coefficient of x is 1, to make this a complete square, so we write x squared plus 6x. Now we are supposed to add 6, which is the coefficient of x, divide by 2, all this squared is equals to minus 3. And because we have modified the left hand side, we also do the same to the right hand side. So we also add 6 divided by 2 into bracket square, so that we balance our equation. So this becomes x squared plus 6x plus, now this is 6 divided by 2 is 3, so it is 3 squared is equals to minus 3 plus, now 6 divided by 2 is 3, then you square, you get 9. So when you now factorize this, you'll be able to get 1x and 1 3. So you have our x plus 3 divide into bracket squared is equals to, now this is minus 3 plus 9, so we get 6. when we get 6, we get the square root for both sides. The square root for both sides. The square root for this side is x plus 3. So the square root of 6 is equals to, so this will be plus or minus. It will be plus or minus the square root of 6. Now, this is we take 3 to the right hand side, so we have x is equals to, it becomes minus 3 plus or minus the square root of 6. When you get the square root, so we can say here that x is equals to minus 3 plus the square root of 6 or minus 3 minus the square root of 6. Using a calculator, then you find x is equals to minus 0.55 or minus 5.45. That is to 2 decimal places. This to 2 decimal places. So the solution to this quadratic equation, x is minus 0.55 or minus 5.45. So that's how you solve this quadratic equation using complete the square method. So in our example 2, we are required to solve this quadratic equation, x squared plus 4x plus 2. So if we try factorization method, let's say we have a plus b should give you 4, and a multiplied by b should give you 2. We cannot get any numbers that can satisfy these two conditions, and therefore it is not possible to use factorization method to solve this equation. So we use a complete the square method to solve this. So we write our equation like this. So we have x squared plus 4x. We take 2 to the other side, it becomes minus 2. So we look for a number that we can add here to make this a perfect square. So when coefficient of x is 1, then we say that we are supposed to add. So we have x squared plus 4x plus 4 over 2 into bracket squared. That is, have the coefficient of x squared, and this is equals to minus 2. We add what we have added to the left hand side, so we add 4 over 2 into bracket squared. So this is x squared plus 4x plus 2 squared is equals to minus 2 plus this is 2 squared, which is the same as 4. Now we get the factors, and this will get the factors are, we take 1x here and 1 2 there, so we have x plus 2 into bracket squared, so those are the perfect squares for the left hand side, is equals to minus 2 plus 4 that will give us positive 2. In this lesson, we are going to cover the quadratic formula. So far, we have learned two methods of solving quadratic equations. The first one was factorization, and the other one was complete the square method. So in this method, we are going to complete the square of a general quadratic equation. A general quadratic equation is of the form ax squared plus bx plus c is equals to 0. So completing the square will give us the quadratic formula. So let's complete the square of this general quadratic expression and see what you get at the end of it. So this is a general quadratic equation. We make it a perfect square, so we take c to the right hand side. So we have ax squared plus bx is equals to minus c. We make the coefficient of x squared to be 1. We divide by a, divide by a, divide by a. So a divided by a, we get 1. So our equation now we get, it is x squared plus b over a x is equals to minus c divided by a. From there, to make this a perfect square, we find what we can add here. So we add the coefficient of x divided by 2. So our expression will be x squared plus b over a x plus b over 2a. That is, we have divided b over a by 2, and then we square, should be equals to minus c over a, and we add the same, that is b over 2a into bracket squared. Now we can make this a perfect square. So we have our x, we get our x is x plus b over 2a into bracket squared is equals to minus c over a plus into bracket b over 2a into bracket squared. From there we'll get the square root of both sides. So the square root of this side and the square root of this side. So we will have our x plus b over 2a is equals to plus or minus the square root of minus c over a plus b over 2a into bracket, this is square. Now when we square the right hand side, then we will have our x plus b over 2a is equals to plus or minus the square root of minus c over 2 over a plus b squared over 4a squared. We can get the, this is a, we can get the LCM here. So we have our x is equals to, we take b over 2a to the other side, so it becomes minus. So we have b over 2a plus or minus. Now we write this as the LCM here is 4 squared. So it is a square root of, this is LCM is 4 squared, 4a squared, 4a squared divided by a, we will have 4a. So we will have minus 4ac, and then we have plus b squared. So we can get the square root of this 4a squared. It will be 2a. So we will have x is equals to minus b over 2a plus or minus. Now we get the square root of, we can start with the b squared now, minus 4ac divided by, now the denominator, we get 2a. Now if you look at now this here, minus b over a, and this other side we have a common denominator. So we now have our x is equals to minus b plus or minus the square root of b squared minus 4ac. All this is divided by 2a. So this is our quadratic formula. So what you need to do is to identify the coefficient of a given equation, and you substitute here, and you'll be able to get the solution to the quadratic equation given. So let's do several examples so that you understand how we apply the quadratic formula. Our example 1, solve this quadratic equation using quadratic formula. So we have x squared minus 2x minus 7 is equals to 0. So the first thing you do is to identify the coefficient and the constant. So we can see here that our a, the coefficient of x squared is 1. The coefficient of x is minus 2, and the constant is equals to minus 7. We have derived the quadratic formula, and the quadratic formula is written like this. It is important you master this formula. X is equals to minus b plus or minus the square root of b squared minus 4 multiplied by a multiplied by c. All this is divided by 2a. We now substitute our constant here, that is for a, b, and c, and we say x is equals to minus, our b is minus 2, so we have minus 2, plus or minus the square root of minus 2 into bracket squared minus 4. Our a is 1 and our c is minus 7. So minus 7, close the bracket. All this is divided by 2 multiplied by our a, which is 1. Now we can now solve this by saying this is equals to, that is our x is equals to minus 2 multiplied minus 2, it will be give us 2, plus or minus, we get the square root. Minus 2 squared is 4. Here we have minus 7, and here we have minus 4. So minus and minus will change to positive. So we have plus 28. All this is divided by 2. From there, we now have this is equals to 2 plus or minus the square root of this will give us 32 divided by 2. You get the square root of 32, and you get it is 5.66 using a calculator. So we say our x is 2 plus or minus 5.66 divided by 2. So this gives us a 2 plus 5.66 divided by 2 or 2 minus 5.66 divided by 2. Now you can use your So in this lesson we are going to cover the formation of quadratic equations. So quadratic equations can be formed from given factors and given a given situation. And I can say that this, when we talk of given situation, can be considered as application of quadratic equations, whereby we use the quadratic equation. We are given a certain situation, we form a quadratic equation, and using the methods that we have learned, then we are able to get the solution to the given equation. So in this lesson, I'll do for you several examples, and then later on I give you an exercise for you to do and try it out. So we form quadratic equation when we are given factors. For example, form an equation using the factors minus 2 and 3. So when you solve a quadratic equation, you get factors. So forming a quadratic equation is like going the reverse of solving a quadratic equation. So here you say, we say x plus 2. So that when we equate it to 0, we get x is equals to minus 2. And here we have x minus 3 is equals to 0. So this one, when you equate x minus 3 is equals to 0, you get x is equals to 3. And x plus 2 is equals to 0, you get x is equals to minus 2. So you expand now. So you say x multiplied by x, you get x squared. X multiplied by minus 3, you get minus 3x. 2 multiplied by x, you get plus 2x. And then we have 2 multiplied by minus 3, we have minus 6 is equals to 0. So we have minus 3 and minus 2. Then you have x squared. So minus 3x plus 2x, you have minus x. Then we have minus 6 is equals to 0. So that is how we form a quadratic equation given factors. Okay, another way that we form quadratic equation is when we are given a certain condition. We have an example here. So the figure below shows a right angle triangle. If its area is 15 centimeters squared, find the value of x. So we know the area of a triangle is equals to a half base times height. And since this is a right angle triangle, we have a half. The base is x and the height is x plus 7. This area is equals to 15. We multiply both sides by 2 so that we get rid of this half. 2. So this will give us, we have 2 divided by 2 is 1. So we have x. We multiply x times x, we get x squared. X times 7, we get plus 7x. Then is equals to 30. So we bring 30 to this other side. Then we have x squared plus 7x minus 30 is equals to 0. So we have formed a quadratic equation. Then we can go ahead and solve it. So this we can use the factor method. So this will be, we write x squared plus 12, that is not 12 but 10. We have 10x minus 3x minus 30 is equals to 0. So we have here we factor out x. So we have x into bracket x plus 10, and here we factor minus 3. So we have x plus 10 is equals to 0. So from there we now can get x plus 10 and x minus 3 is equals to 0. So this means that x is equals to minus 10 or 3. Since we are looking for the value of x which represent length cannot be minus, so we ignore minus 10 and say x is equals to 3 centimeter. So that is how you work out such kind of a question, and the quadratic equation help you to get the missing values. So here is another example. The perimeter of a rectangle is 42 centimeter. The diagonal is 15 centimeter. Find the width of the rectangle. So we can find the width. We make a rectangle here so that we are able to identify the area, the width. So we are told that the diagonal is 15 centimeter. So this is our diagonal. So this is 15 centimeter. So we let our width be x. Since when you add the width plus the length, it is half the perimeter, which is 21. Therefore the length is x, 21 minus x into bracket centimeter. So now what we have is we can use this right angle triangle where we have the diagonal is 15 and we apply the Pythagoras theorem. So we say x squared plus 21 minus x into bracket squared should be equals to 15 squared. That is the Pythagoras theorem. So we expand this 21 minus x squared. So we have x squared. When you expand that, it should be x squared plus then we have 441 minus 42x then plus x squared is equals to 15 squared is 225. So we can add up the right terms. So we have x squared plus x squared, we will get 2x squared. We don't have any other effort x, so we say it is minus 42x. We bring 225 to the left hand side, so it will be minus. So 441 minus 225, we get plus 216 is equals to 0. So this is a quadratic equation. We can make it simpler by dividing by 2, divide by 2, divide by 2. So 2 divided by 2 is 1. 42 divided by 2, you get 21. This 216 divided by 2, you get 108. 0 divided by 2 is 0. So our equation now will be x squared minus 21x plus 108 is equals to 0. We can now solve the quadratic expression, and this will give us x, the factors are x minus 12 into bracket, and then we have x minus 9. X minus 9 is equals to 0. So we can now say our x is equals to x is equals to 12 or 9. So you can substitute here. 21 minus 9 is 21 minus 9 is 12. So x is 9. So since we are required to find the width of the rectangle, then we say width is equals to 9 centimeter. So that is how you solve that question. So you can see that after forming the quadratic equation, now that we know how to solve the quadratic equation, it has helped us to find the value of x. So here is another example. Two numbers which differ by 3 have a product of 88. Find them. So this means when you multiply the two numbers, you get 88. So we can let one of the number be x, and since the difference is they differ by 3, the other number we can say it is x plus 3. Now when you multiply these two numbers, you get 88. So you multiply x multiplied by x plus 3, you get 88. We open the bracket and you get x squared plus 3x. We bring 88 to this side, becomes minus 88. So the left hand side is equals to 0. Now we have a quadratic equation which we can now solve. We can use the factor method. We have two numbers, 8 and minus 11. When you add them, you get 3. When you multiply them, you get 88. So we can write our equation like this: x squared plus 11x minus 8x minus 88 is equals to 0. So we factor out what is common. So here we will factor out x, and when you factor out x, inside you will be left with x plus 11. The other side, this will factor out minus 8. So we'll be left with x plus 11 is equals to 0. So this we can now get the factors: x plus 11, close the bracket, and x minus 8 is equals to 0. Welcome to the 6th lesson of quadratic expressions and equation. In this lesson, we are going to learn how to draw quadratic graphs of quadratic functions. So we are given when y is equals to x squared, y is said to be a function of x. So let's take an example and see how we draw the graph of a quadratic function. So example 1, write the graph of y is equals to x squared minus 4x plus 4 for the range minus 3 less than or equals to x less than or equals to 5. So for us to be able to draw this graph of y is equals to x squared minus 4x plus 4, we need a table like the one that I have here. So in this column, we will put the terms of x. So here we have our x, here we have x squared, here we have minus 4x, and here we have 4, and here we have y. So we have obtained this from our function here, x squared minus 4x plus 4. Then from our range which we have been given, we are told x ranges from minus 3 to 5. So we will put our values of x here. So we start with minus 3. We go to minus 2, minus 1, 0, 1, 2, 3, 4, and 5. So that is the range. So in this row where we have x squared, we need to identify x squared. So minus 3 squared is 9, minus 2 squared is 4, minus 1 squared is 1, 0 squared is 1, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. From there we have minus 4x, so it means we multiply minus 4 with the value of x, which is 3. So minus 4 times minus 3, you get positive 12. Minus 4 times minus 2, you get positive 8. Minus 4 times minus 1, you get positive 4. Then minus 4 times 0, you get 0. Minus 4 times 1, you get minus 4. Minus 4 times 2, you get minus 8. Then we have minus 4 times 3, you get minus 12. We have minus 4 times 4, you get minus 16. Then we have minus 4 times 5, you get minus 20. 4 is a constant here, so we just write 4 throughout that row. So we have 4, another 4, 4, 4, 4, 4. So having those values, we now have the value of y. So here, since we have been given x squared minus 4x plus 4, we say 9. So this is x squared minus 4x plus 4. So this is 9 plus 12 is 21 plus 4, we get 25. Then we have 4 plus 8 is 12. 12 plus 4, we get 16. Then we have 1 plus 4 is 5. 5 plus 4 is 9. 0 plus 0 is 0. Plus 4 is 4. This is 1 minus 4 is minus 3. Minus 3 plus 4, we get positive 1. Here is 4 minus 8 is minus 4. Minus 4 plus 4, we get 0. Then we have 9 plus minus 12 is minus 3. Minus 3 plus 4, we get positive 1. Here we have 16. Minus 16 is 0. 0 plus 4, we get 4. Then we have 25 minus 20 is 5. 5 plus 4, we get 9. So what this means is that when x is minus 3, y is 25. When x is minus 2, y is 16. When x is minus 1, y is 9. On and on up to when x is 5, y is 9. So these are the values that we are going to plot on a graph paper so that we will be able to get the graph represented by this function. So before we plot the graph, we need to identify the lowest value of x is minus 3. Lowest value of x is minus 3, and the highest value of x is 5. The lowest value of y is 0, and the highest value of y is 25. So this will guide us in plotting our Cartesian plane so that we know how high is a value of y, and how far horizontally is the value of x. So this is our graph paper. We have the grid. We have the table that we have discussed in there before. So we have the values of x and the values of y. So the first thing is to draw the xy axis. So this will be our starting point. So we say that the value of x, the lowest is -3 and the highest is 5. So we have 1, we have 2, 3, 4, and 5. So that is our x-axis. On the negative side, we have -1, we have -2, we have -3. This is 0. So why? Because the highest value, the scale is, we use a smaller scale. So here from 0, we say this is 5, this is 10, this is 15, this is 20, and this is 25. So that is our x-axis. We read the value from the table so that we are able to identify the various points. So when x is -3, y is 25. So we come here, x is -3, we go up to where we have y is 25. We put a mark. When x is 2, y is 16, -2. So -2, the scale of y, this is our y, 2 small squares are representing 1, so 16 is there. When x is -1, y is 9, so this is -1, 9 will be there. When x is 0, y is 4, so 0, we have y is 4. When x is 1, y is 1, so we have, that is our 1. When x is 2, y is 0, so that is our y. When x is 3, y is 1, so we have 1 there. When x is 4, y is 4, so that is our value of 4. Then when x is 5, y is 9, so y is 9, that is where our y is. So from there, having identified the various points of x and y, then you use you draw a line touching all these points, and you use your free hand. You don't use a ruler. So let's draw the function. Welcome to this lesson. In this lesson, we are going to learn how to solve quadratic equation using graph, and that is what we are calling graphical solutions to quadratic equations. We have learned other methods, that is factor method, complete the square method, a quadratic formula, and now this is another method of solving a quadratic equation. In lesson number 6, we learned how to plot quadratic graphs, and we are going now to practice that knowledge and see how the graph helps us to solve a quadratic equation. So you are welcome, and by the end of this lesson, you should be able to solve a quadratic equation using a graph. In our example 1, we are going to consider the quadratic equation x squared plus x minus 6 is equals to 0. So you can solve this quadratic equation using the factorization method, completing the square method, or the quadratic formula. I'm going to use the factorization method to solve this equation, and then you would see how now we apply the graphical solution to quadratic equation. So we can write this equation as x squared plus 3x minus 2x minus 6 is equals to 0. From there, we factor out x here, so you have x plus 3, and here we factor out minus 2, this and this, so we will be left with x plus 3 into bracket is equals to 0. We factor out x plus 3, so you have x, this is x plus 3, and we'll be left with x minus 2, which is equals to 0. So the factors of these quadratic equations are x is equals to minus 3 or 2. So that's how you solve the quadratic this quadratic equation. Let's now solve this quadratic equation using the graphical method and see whether we'll be able to get the same factors, or how we get the factors minus 3 and 2. Let's now plot the graph of y is equals to x squared plus x minus 6. We are going to plot this graph within the range of from minus 5 less than or equals to x less than or equals to 3. So here we put our x like we have learned when we are plotting the graphs. So here we have x squared, we have x, we have minus 6, which is a constant, and finally we have y. Then we put the values of x, so we start with minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, and finally we have 3. With that we fill the table, so minus 5 squared we will get 25, positive 25. Minus 4 squared we get positive 16. Minus 3 squared we get 9, positive. Minus 2 squared we get 4. Minus 1 squared we get 1, 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. Then we have x. X, we just put the values of x that we have in our first row. So here we have minus 5, here we have minus 4, here we have minus 3, we have minus 2, minus 1, 0, 1, 2, and 3. 6 is a constant, so we just fill minus 6 throughout this row. A constant does not change. Then finally we now compute the value of y. So 25 minus 5 is 20. 20 minus 6 we get we now get 14. So our value here is 14. 16 minus 4 is 12. 12 minus 6 we get 6. 9 minus 3 we get minus 6. We get 6. 6 minus 6 is 0. 4 minus 2 is 2. 2 minus 6 we get minus 4. 1 minus 1 is 0. Minus 6 we get minus 6. 0 plus 0 is 0. Minus 6 we get minus 6. 1 plus 1 is 2. 2 minus 6 we get minus 4. 4 plus 2 is 6. 6 minus 6 is 0. 9 plus 3 is 12. 12 minus 6 we get positive 6. Now with these values of x and y, we will be able to plot the graph of the function y is equals to x squared plus x minus 6. So this is our graph paper. We first of all make the Cartesian plane. So along the x-axis we have, let's say we have 0 here. Here we have minus 1, minus 2, minus 3, minus 4, and finally minus 5. Then the positive side we have 1, 2, and 3. So this is our x-axis. Then our y-axis, we use a different scale because we will need positive 14, the highest value, and negative 6, the lowest value. So we can use the big square to represent 5 units. So 5, we have 10, we have 15, and we have 20. So this is our y-axis. Then the negative side, we have minus 5, we have minus 10. So that will cover all that we need to make our graph. From there, we read the values to identify the points from the table that we have prepared. So when x is minus 5, y is 14. And therefore, we are going to identify that point. When x is minus 5, y is 14. So you note that the two small squares represent 1 unit. So that is where we have our 14. When x is minus 4, y is 6. So minus 4, this is minus 4, y is 6. We identify our point there. When x is minus 3, y is 0. So x is minus 3, y is 0. So that's where we have our point. When x is minus 2, y is minus 4. So minus 4 is there. When x is minus 1, y is 6. So y is there. When x is 0, y is minus 6. So this is where we have minus 6 when x is 0. When x is 1, y is minus 4. So minus 4 is there. When x is 2, y is 0. So this is where we have our point. And finally, when x is 3, y is 6. So that is where we have the point. So with this point, we are going to plot the quadratic graph by joining these points using freehand, and then we will label our graph. So this is our quadratic graph of y is equals to x squared plus x minus 6. Now, what do we observe about this? Welcome to this lesson. This is a graphical solution of simultaneous equations. In this lesson, we learn how to solve a linear and a quadratic equation together using a graph. We are going to do that by use of examples, and later we will have an exercise for you to try out and see whether you know how to solve these simultaneous equations. So in our example 1, solve the following equations simultaneously. So this is a quadratic function. which we can get the equation x squared plus 2x minus 2 is equals to 0. This is a linear function. So we are going to plot these two graphs and then see what solutions we'll be able to get from our graph. So we are going to prepare a table that is going to assist us to plot the graph of the function y is equals to x squared plus 2x minus 2. So we'll plot our graph within the range of -3 less than or equals to x less than or equals to 4. So we start by filling our table. So here we have our x, we have our x squared, then we have 2x, we have -2, and finally we have our y. Then the first row we fill the range of x, so it is from -3, so we have -3 there, -2, -1, 0, 1, 2, 3, and we have 4. So we now fill the table. X squared, so minus 3x minus 3 squared is the same as +9, minus 2 squared is +4, minus 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. From there we get 2x. So our 2x is, we multiply the 2 by the value of our x. So this is 2 multiplied by -3, we get -6. 2 multiplied by -2, we get -4. 2 multiplied by -1, we get -2. 2 multiplied by 0, we get 0. 2 multiplied by 1, we get 2. 2 times 2, we get 4. 2 times 3, we get 6. And 2 times 4, we get 8. From there, we have 2 is a constant. So we fill that row with 2. So you'll find in some book they omit this row, but I find it important because it makes you not forget the constant. So we now get our y. Our y will be 9 minus 6 is 3. 3 minus 2 is 1. 4 minus 4 is 0. Minus 2, we get -2. 1 minus 2 is -1. Minus 1 minus 2 is -3. 0 plus 0 is 0. Minus 2, we get -2. 1 plus 2 is 3. Minus 2 is 1. Then we have 4 plus 4 is 8. 8 minus 2 is 6. 9 plus 6 is 15. 15 minus 2 is 13. 16 minus 8 is 8. 8 minus 16 plus 8 is 24. 24 minus 2 is 22. So we can now be able to plot the graph of y is equals to x squared plus 2x minus 2 using the values of x and the values of y. So we are going to plot that graph. So we are going to plot the graph of the function that we have here. I have already inserted the table for convenience so that we can be able to read the values of x and y. So we plot our Cartesian plane. So we have 0, 1, 2, 3, 4. So that is our x-axis. The negative side we have -1, -2, -3. Then we have our y-axis. So we use a different scale. So this is 5, this is 10, this is 15, 20, 21. So that is our y-axis. Always remember to label your axis. Then the negative side we have minus 5. From there, using our table, we identify the point. So when x is minus 3, y is 1. So one small square represents 1. So we have our x there. Then when x is minus 2, y is minus 2. So that is where we have our mark. When x is minus 1, y is minus 3. So 1, 2, 3. So that's where we have our mark. When x is 0, y is minus 2. So we have minus 2 there. When x is 1, y is 1. So that is our point. When x is 2, x is 6. So that is where we have our 6. When x is 3, y is 13. So we have 1, 2, 3. That's where we have 13. When x is 4, y is 22. So 20. This is 25. So we have 21, 22. We have our mark there. Not actually there, but when x is 4, we have 1, 2. So with this point now, we will be able to plot the quadratic graph represented by this function. So this is our quadratic graph. We now label our quadratic graph. It is y is equals to x squared plus 2x minus 2. From there, we are going to plot the graph of the other linear equation which we had been given. So let's go back to the question and make a table for that linear graph. So we now make a table that to assist us to plot the graph of y is equals to x plus 1. So this is a linear function. We need at least 3 points. So we make a table. So this is our x and this is y. So we say when x is 0, or let's start minus 1, then minus 1 plus 1, y will be 0. When x is 0, we substitute 0 here, so y will be 1. When x is 1, so x is 1, so it is 1 plus 1, you get 2. So we use this table to plot this linear graph. We now have the table for the function y is equals to x plus 1. So we are going to identify the 3 points which will help us to come up with a straight line. So when x is minus 1, y is 0. So this is where we have minus 1 and y is 0. We use a dot to represent that. When x is 0, y is 1. So x is 0, y is 1. So it is there. When x is 1, y is 2. So x is 1, y is 2. So that is where we have our point. With these 3 points, we will be able to draw a straight line by joining them to come up with the linear graph. So this is a linear graph. We label it. It is y is equals to x plus 1. From Welcome to this lesson. This lesson is known as Further Graphical Solution. In this lesson, we are going to learn how to solve other equation using a quadratic function, one quadratic function. So you can use one quadratic function graph to solve other related quadratic equations. So we are going to do that by use of an example. and you are all welcome. So let's have a look at our example 1. So our example, use the graph of the function y is equals to 2x squared minus 5x minus 2 within the range minus 2 less than or equals to x less than or equals to 4 to solve the following quadratic equation. So we have our first equation, 2x squared minus 5x minus 2 is equals to 0. The second one, 2x squared minus 3x minus 2 is equals to 0. The third one, 2x squared minus 5x minus 3. And finally, 2x squared minus 2x minus 8. Many students, when they come across such kind of a question, they tend to draw the graph of our function here, and then they plot the graph of these equations. So that is not the way it is done. You only plot one graph of the function and then use that graph to solve this equation. So let's go ahead and see how it is done. So we'll prepare a graph or a table to help us plot this function. The graph of y is equals to 2x squared minus 5 minus 2. So we now put the value of x here. We put x squared, then we put 2x squared. From there we have minus 5x, we have minus 2, and finally we have y. X ranges from minus 2, so we put our minus 2 there, minus 1, 0, 1, 2, 3, and 4. Then now we fill the table. X squared minus 2 squared is positive 4. Minus 1 squared is positive 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. Then we now multiply the x squared times 2. So this is 2 times 4. We get 8. 2 times 1 you get 2. 2 times 0 you get 0. 2 times 1 we get 2. 2 times 4 we get 8. 2 times 9 we get 18. 2 times 16 we get 32. From there we get now the minus 5x. So this is minus 5 multiplied by minus 2. You get positive 10. Minus 5 times minus 1, you get 5. Minus 5 times 0, you get 0. Minus 5 times 1, you get minus 5. Minus 5 times 2, you get minus 10. Minus 5 times 3, you get minus 15. Minus 5 times 4, you get minus 20. Then now we get the constant. 2 is a constant, so we fill that row with the constant 2. Then we compute our y. So we'll start from where we have our 2x squared. So this is 8 plus 10 is 18. 18 minus 2, you get 16. This is 2 plus 5 is 7. Minus 2, you get 5. 0 plus 0 is 0. Minus 2, we get minus 2. 2 minus 5 is minus 3. Minus 3 minus 2 is minus 5. 8 minus 10 is minus 2. Minus 2 minus 2 is minus 4. 18 minus 15 is 3. 3 minus 2 is 1. 32 minus 20 is 12. 12 minus 2 is 10. Now with the values of our x, so when x is 2, y is 16, x is minus 1, y is 5. Then up to when x is 4, y is 10, we will be able to use these values to draw the graph of this function. So let's go ahead and do that. Now here is our graph paper. So we are going to plot the graph of the function. So we have the x-axis. We start from here. It is 0, 1, 2, 3, 4, 5. So that is our x-axis. Then we have -1, -2. And the y-axis, we have the highest value is 16. So we can say this is 2, 4, 6, 8, 10. Then we have 12, 14, 16. So this is our y-axis. Then we have the negative side. This is -2, -4. So that is -4, and this is -5. So we now mark our points. When x is -2, y is 16. So -2, we go up to where we have 16. We make our mark there. When x is -1, x is 5. So -1, 5 is there. When x is 0, y is -2. When x is 1, y is -5. So this is where we have -5. When x is 2, y is -4. So we have our point there. Y is -4. When x is 3, y is 1. So y is 1. When x is 4, y is 10. So when x is 4, y is 10. From there, we will now join our points to come up with the quadratic function or the quadratic graph. So this is the graph of the function. So we label our graph y is equals to 2x squared minus 5x minus 2. We are supposed to use this graph to solve the equation 2x squared, that is Roman number 1, minus 5x minus 2 is equals to 0. If you look at our function here, that is y is equals to 2x squared minus 5x minus 2, and our equation, you can see that y is